my presentation dealing with a new project in Milano, but let's say I will not present it directly through the architecture, just more regarding engineering approach. And well, the general concept is, again, transparency. Transparency means many things in terms of architecture, of course, of feeling the architecture, but from an engineering point of view of the facade, normally transparency is quite a big complications into the design. So we will see some issue. So very, very fast the introductions of this new building. As you have seen, that is a new library. So the new European library in Milano dealing with information and culture. Well, the building is currently under construction, and it is placed in an area of Milano of refurbishment, so one of the most important large area of Milano, considering that in this area before there was like a historical railway station, as you can see from the picture. Yeah, so very quickly, this is the plan of the building. So you see that it's divided in different parts or components, like departments in the forum area and in imaginarium area that is mainly at the ground floor. So underground there is the largest part of the building, which is dedicated for storing most of the library informations and books. So this is a rendering of what is the transparency or the aim of the transparency of the building. Well, as you see, well, the building is highlighting the transparency, which is concerned with the information and culture. So something which sounds like transparency of the knowledge that we can have through the library. Well, and as you can see from the rendering, the transparency means, of course, a very light construction, so the structure, but a very light facade too. So mainly glass again everywhere. So dealing not only with the facade directly, but also with the roof. So this is, let's say, something which is dealing with the structure. I will not get through the structure, but only to explain the complexity of matching the facade construction with the structure of the building. So the structure of the building is a mixture, of course, of a concrete structure, which is mainly underground, and what is a typical steel structure on the, let's say, ground floor and the top of the building. Well, as you see here from the picture, well, very shortly, that is the spanning of the structure is quite complex and very high. So we have to match the facade structure with the building structure. So that is a problem which regard, of course, the detailed design developed by the architect, by the consultant, and also what is under construction. Today, within the audience, there are a couple of colleagues working directly on this project, and they are on the side of the construction detail design. So just we moved from the architectural approach to directly to the curtain walling construction. So let's say that in this case, the building is designed with a double skin facades, not everywhere, but mainly on the fronts of the building. The system which has been studied from the, let's say, detailed design is a typical stick system approach. So stick system, which is connected to mainly a steel structure. So here you see some very short details about the facade system. So that is a typical double skin facade with a metal deck in the middle. So we have for maintenance access. And then, of course, we have an outer screen, which is made mainly by grid panels that are able, of course, to provide shade to the very high transparent facade, which is on the back. Well, where is the problem regarding this building? Well, that is the problem of the compatibility between the structure and the facade. So at the beginning, it could seem that is nothing very complicated because we are speaking about a stick system, so something which is very well known. So maybe we can go also to the next one. And we know that we have performances, nevertheless, that they must be assured. So we speak about energy performance, acoustic performance, but particularly, of course, we speak about environmental performances, so in terms of air permeability, water tightness, safety in use. And everything is connected to standards at the end. So due to the fact that we, of course, we overall work into the European markets, we have some standards, and the standard which leading is the product standard EN 13830, which is, let's say, our master standard regarding facade. So what are the problems with these projects? So we have a geometry of the facade. As you have seen, the facade is inclined. So first question is it still a facade or something which is coming roof? Well, if we look to the standard, the product standard for facade stops as 15 degrees of inclination. So everything which is looping more than 15 is no more a facade. But nevertheless, we have the same construction system for the facade from the vertical to the sloped area. So normally is coming a promise regarding Europe for the CE marking of the product, which comes out of the applications of the standard directly. But nevertheless, we have, let's say, performances that they need to be assessed, nevertheless, by the facade. And the other topic is the interface that we have between the structure and the facade itself. So here you see just the approach given to the project. So it started from basically a system, which is a commercial system for the facade. So a stick system that we generally know very well. We know that for stick systems, and also for, let's say, other kind of facades, we have some geometries that must be respected. So particularly, as you see on the top on the left, what we have the glass bite. So the glass bite is something which is dominant in terms of the performance of the facade. But what we have here in this case, as you see on the right side, we have a large construction tolerances and displacement. So what is the risk when we move from, let's say, the approach that we have on the left to find exactly the solution? Is that normally the risk is that we have no more allowance between the structure of the facade, the glass units, and what is expected as interference with the structural deflections or displacements of the building. So this is a typical problem which normally comes out when we look so much to the transparency, so large glass units, and we also look for a very, very light structure. So of course, this is what we have on the right side. That is the typical approach that we have to the problem. And we know that standards are able to define displacements expected, but not for the structure, expected for the facade frame in terms of wind load resistance or in terms of horizontal live loads. We know that we have standards able to fix displacement limits that are given to assure that the facade is able to maintain performances like air permeability, water tightness, under serviceability. But as we said, here we are just moving from, let's say, typical standard system to something which is customized, even if the original idea is to move from a system selected on the basis of commercial data, because of course the project also needs to answer to a, let's say, cost limit due to the fact that this is a public building. So what it means in terms of construction, that we have a standard stick system where we have a dominant system width, and we have to move to something which is different. So to a system which is able to allow the different displacement between the structure and the glass units. And this is what we see on the right. So of course I cannot present you everything because of course the project is under development, but just to explain you what is the passage from, let's say, what is in the original design to what is into the constructions, as you see here. What is the difficult here that we need to also carry? What is about the passage from the vertical facade to the inclined one? Because again, of course, all the performances tests that we can have with a stick system, which is already certified, are valid for the CE marking only on the vertical up to 15 degrees. So we have also, in this case, the situations where we have to test the inclined situations like the one you see on the right. Okay, so just coming to by train this morning, Well, I thought, why I have only to speak about stick system? So is it a problem, the compatibility between structure and facade, only a problem of the stick system in the facade industry, or is it generally something which is coming out from the approach that we give to architecture currently? So this is another project in Milano, which is currently under development or mostly completed for, let's say, the facade. But again, you see that the discussion here is the very challenging structure that we have with overhanging parts. So these overhanging parts means that we have different displacements according to the different floors. So the building is mainly made of, let's say, unitized system in this case, except for the central part of the elevation you see here. So in that case, it's a stick system. What is typical of this building is that the structure is challenging because we have cantilevered part, and they are post-tension system for the structure. So we expect from the structure a large vertical displacement, particularly for the shrinkage of the structure, which is made of concrete. So just I have highlighted the different parts. So lower floors or lower slabs and high-rise slabs. We know that the system in this case, I said here, is let's say a unitized. So what is typical in the unitized? It is the stuck joint. So this is the example taken from the building of the installation phases. Well, the building is particular because you have seen that the stuck joint is not at the floor level, but is at the level of the sill. And the sill varies from floor to floor. So from 45 centimeters up to 90 centimeters above the floor level. So what is here? The problem is, again, the structural displacement. So maybe you can see that just going on the next slide, that we have simulated a little bit what are the expected structural displacements, mainly given by dead load and as I said you, by fluage problem. So here the problem is to have two different stuck joints according to the different floors. So we have lower rise floors, what could be, let's say, more or less a very standard stuck joint into the unitized system, about 23 millimeter, just to allow all the different displacement of the structure. Well, in the high-rise floors, we have something which is quite unusual. So we have 50 millimeter of stuck joints to accommodate the displacement of the structure. So again, here is the problem that means that we go a little bit out of what is a standard. And therefore, for this building as for the other one, the necessity and the opportunity to test different situations just to, let's say, being able to accommodate displacements and assuring performances. Well, so coming to the conclusions of my presentations. Well, my idea is that, of course, we have to fix standards. I work a lot in standards, as you know, but standards are not able to catch everything, even if they run after development of architecture and industry. Well, it is therefore very important to just have clearly different stage of design from the concept to the construction. Well, also that testing nevertheless is very important. Testing because even if we are able to certify, let's say, standard systems, the certification are not being able to be extended to all the different cases. So nevertheless, we have to test what we design, and particularly when we design something which is mainly customized. Well, the last topic is that I see that the complexity is coming out very much in the integration between the structure and the facade design. So, as I said before, well, we have standards dealing with displacement according to the performance of the facade, but we do not have clear displacements into our standards regarding structure, when these structures are connected to a very sophisticated envelope systems like the case of the curtain walling. So I think that, just regarding the last bullet, one of the next steps, according to the standardization activity, could be to, let's say, work much more in joining with the structural engineers, finding also a good possibility to fix, let's say, structural displacements according to the different technology that we can adopt for the building envelope, particularly considering curtain walling. So thank you very much.